Okay, so we're going to look at the modulus function. So this is obviously part of the lecture series on specialist maths units 3 and 4. And so what we're going to look at is we'll look at the modulus function and what that is. Then we're going to look at properties of it. And then we'll look at functions of the form modulus of f of x and functions of the form f of mod x. So let's just jump into it and see if we can make some sense of it. Basically, the modulus function is a hybrid function, and it's this. It says if x is negative, so for x less than 0, you're going to graph the line negative x. So that's this line here. If otherwise, so if x is greater than or equal to 0, you're going to graph the line f of x equals x. So you end up getting this situation where you get this sort of V shape. And this point here is continuous because this side is less than 0, and then this side is greater than or equal to 0. But you get a situation where you get what's called a cusp here. So it's actually not differentiable at that point, which will be important later on. For now, all we need to be aware of is, that this f of x equals mod x is essentially this function. And this is what it looks like. Sort of draw it in two parts. So from there, what we can actually do is we can talk about properties of that function. And sometimes it's also known as the absolute value. So if we look at property 1, it's really two properties put together here, but it says the absolute value of A multiplied by the absolute value of B is equal to the absolute value of A times B. And that should make sense. If we just have a look down here at an example, if we pick some random numbers for A and B, if A is negative 3 and B is 2, well, the absolute value of negative 3 is 3. So this is going to be 3 times 2. So we can see that the left-hand side equals 6. We can also see that inside the absolute signs on the right, we've got negative 3 times 2, which is negative 6. Take the absolute value of that, gives you positive 6. So we can see that this property kind of holds for the modulus function. The same is true with division. The absolute value of A divided by the absolute value of B is equal to the absolute value of A over B. And again, pick some numbers and see that that works so that you're satisfied with that. That's the first property. The next property says this. It says if the absolute value of x equals A, this implies that x equals A or x equals negative A. So what we can say is, again, look at an example. If we pick x being negative 3, we then take the absolute value of that. So we get the absolute value of negative 3 being 3. And so A could have been, negative 3 or positive 3. I had that the wrong way around. Maybe you noticed. So my bad. But let's have a look here. If A is 3, so we set A to be 3, we just pick some value, and we say that the modulus of x equals 3, then x had two options, didn't it? It could have been negative 3 or positive 3, because the absolute value of negative 3 is positive 3, and the absolute value of positive 3 is just positive 3. So that's sort of an extra second property of the modulus function. Let's look at property 3 here. It says the modulus of A plus B is always less than or equal to the modulus of A plus the modulus of B. I think the best way to show this is with a diagram. So let's just look at a triangle here and just think about the length of these vectors. Imagine we've got some vector A, it's sort of pointing in this direction, then some vector B here. Just take my word for it for now. If you add these vectors together, you basically get this line here, which is vector A plus B. And what it's saying is essentially the length of A plus the length of B is always greater than or equal to this length. And that should make sense. If you needed to get from this end of a field to this end, quickest way is obviously going to be to walk directly to it, right? Going this way is obviously going to take longer. So it's just saying that the sum of this length plus this length is always greater than or equal to this length. And you're probably wondering, when can it be equal to it? And I was wondering that. Basically, if you've got what's called a degenerate triangle where A and B are parallel to each other, then you would get that they're actually on top of each other. So yeah, your triangle sort of doesn't exist at that stage. It's called a degenerate triangle. So yeah, there you go. That's another interesting property of the modulus function, sometimes called the triangle inequality. All right, let's have a look at one of the last properties here. Property 4, if A and B are both positive or both negative, the modulus of A plus the modulus of B equals the modulus of A plus the modulus of B. Okay, and that should make sense. If we were to do a substitution in here, in fact, I'll put some numbers in to help. Yeah, so here's just some numbers to help explain this idea. If they're both negative, well, let's take A being -3 and B being -2. So -3 plus -2 is -5. And then on the right-hand side, we'd have the absolute value of -3 plus the absolute value of -2. So you can see that these are clearly equal to each other. The absolute value of -5 does equal the absolute value of -3 plus the absolute value of -2. So as long as the signs are the same, this property will hold true. It's obviously not true if you have different signs on A and B. If A is positive and B is negative, for example, that won't work. Okay, so that's sort of our fourth property there. Let's have a look at some other properties. This is another interesting property. So if A is greater than or equal to 0, then the modulus of x is less than or equal to A is the same thing as x being between -A and +A, inclusive. So let's maybe show what's going on here. We know now what the modulus of x function looks like. It's sort of this V shape that we've got going on here. If we pick some value for A, we've got a slider for A here that's greater than 0. So here we go. We've got this value of A that's greater than 0. Let's put it to like 4 or something. Okay, so A is greater than or equal to 0, then the absolute value of x is less than or equal to A. Well, hopefully, or then I'll rephrase it. Then the absolute value of x has to be less than or equal to A is the same thing as x being between -A and +A. So you can see that we've sort of got this boundary going on here. A at the moment is 4. We can see that the x values that it takes on are between -4, so -A, and +A. That is when the modulus of x is less than or equal to A. And that should make sense because the sort of between here and here is when this function, the mod of x, is less than or equal to A, is below that black line there. So you end up with this situation where you're sort of getting this going on. Obviously, this doesn't hold when A is less than 0. But when anytime A is greater than 0, saying this is the same thing as saying x is between -A and +A inclusive. All right. So hopefully that made a bit of sense. Let's have a look at the next one and let's just let this play for a moment because I think it looks cool. And it kind of looks like that thing on the TV when the DVD symbol sort of tries to hit the top left-hand corner and right-hand corner. And yeah, we just sort of get this interesting situation going on. Let me explain what this is all about. Let's pause this. Basically says if A is greater than or equal to 0, then the modulus of x minus k is less than or equal to A, is equivalent to k minus x being between k minus A and k plus A inclusive. So let's explain what's going on here. Let's put k to be +1. If it will let me. And let's put A to be, oops, that's not what I wanted. Let's put k to 2. Okay. All right. So A is greater than or equal to 0. Then the modulus of x minus k. All right. What this k value does is it shifts everything to the right. So when k is 2, this has all been shifted to the right. And we can see again that the boundaries are going to be now between k minus A. All right. 2 minus 3 is -1. And 2 plus 3 is 5. So we can see that, yeah, saying that the modulus of x minus k is less than or equal to A is the same thing as saying that x is between k minus A and k plus A inclusive. And yeah, we can see sort of through this diagram that that's the case. So yeah, have a think about that because I think it's actually not that straightforward to think about, but it's an interesting property nonetheless. Okay, let's now look at functions with the rule modulus of f of x. So let's just jump into an example straight away. So let's look at the function f of x equals x squared minus 2x. Now, hopefully this is a pretty standard quadratic by now. If you were to factorize this, you would get x multiplied by x minus 2. And what that means is you get an x-intercept at the origin and at the point x equals 2. So you'd end up with this, something that looks like this. Now I'm just going to show you the result straight away. If we were to do modulus of f of x, we'd actually get something like this going on. And I think you would agree if we sort of swap between them, essentially what's happened is this part that's below the x-axis has been reflected in the x-axis. And you sort of get this situation going on where it sort of bounces on the x-axis. And the reason for that is what's stated here. The modulus of f of x is equal to f of x if f of x is greater than or equal to 0. So anywhere where it's positive, you're all good. You don't need to worry. You don't need to do anything different. You notice all this part is the same and all this part is the same because f of x is greater than or equal to 0 already. So we taking the absolute value does nothing, right? But what does happen is when we take the absolute value when f of x is less than 0, or anything that's f of x being less than 0 is anything below the x-axis. So that all gets, anything that's below the x-axis gets flipped up. And so that's how we take the absolute value of a function. We basically reflect anything where f of x is less than 0 in the x-axis. So we get this, the modulus of f of x equals negative f of x if f of x is less than 0. So that is functions with the rule mod f of x. Okay, last one we're going to look at is functions with the rule f of modulus x. And again, I think an interesting thing would be to just look at an example. So if we've got f of x equals x squared minus 2x, that's again the same graph we had before. Let's see what happens if we do f of mod x. I mean, not getting something like this, sort of a W shape going on, right? And what we want to do is we want to think about, well, why is that the case? I encourage you to think about what's sort of going on from here. And maybe you notice it's something to do with reflecting in the y-axis, or it looks like it is anyway. It's sort of being taken. It's been taken from over here, and then it's sort of been put up here, right? And so let's see what this says. So if f of mod x equals f of x, so I'll say that again. Try again. F of mod x equals f of x if f of x is greater than or equal to 0. 1 second, that's not right. Okay, that looks better now. So I just copied it from the other one, but I needed to change this. So now we're interested in the input values, right? We need the input values that we're putting in, taking the absolute values of those. So f of the modulus of x equals f of x as long as x is greater than or equal to 0. So anything to the right of the graph stays the same. Anything where x is positive, you'll notice it's actually going to stay exactly the same. It's going to look like that. Anywhere, however, we can say this, f of mod x equals f of negative x if x is less than 0. Because we're taking the absolute value of the input values, we basically can't have any negative input values. So the effect of that is to reflect everything in the y-axis. So we end up with something like this. So if x is less than 0, so anywhere over here, we're going to get f of negative x as our output values over here. And again, sort of looking at the structure here, where x is greater than or equal to 0, we have x, and negative x where x is less than 0. So that is sort of the structure of the modulus function that we spoke about back here, right? So yeah, hopefully that clarifies things a little bit. Basically, f of mod x, you're going to reflect any negative x values in the y-axis. And then that's how you sketch it. So hopefully that clarifies things a little bit, and good luck with everything you're doing. I'll talk to you soon.